once we figured out the northing and eastings, we're going to now use this value to correct for the indirect method. So we're going to use the northing and eastings to solve for our bearing, change it to an azimuth, and get a new length between the lines. So here is our adjusted departures and latitudes. So we've got, these are the corrected ones. So the new length, remember, is just a right triangle, a squared plus b squared equals c squared. So we're looking for the c squared, the hypotenuse. So we're going to take our departure squared plus our latitude squared, and then take the square root of that. And that'll give us the new lengths between each of the traverse points. And then lastly, we'll figure out what the bearing is and then convert it to the azimuth. And the bearing, remember, if you look at this, the tangent of a line is going to be the departure over the latitude. Now, again, so for example, we're always coming from the north down. So that's why it's opposite over adjacent. So that's why it's departure over latitude. So the first thing we're going to do is we're going to take our latitudes squared plus our departure squared and take the square root, and then we'll get a new length. I'm going to go ahead and just do these in a column instead of hopping back and forth. So departure and latitude, take those, square each one of those, and then square root, so we get our new lengths. Now we're going to take the tangent, and we're going to go departure over latitude, inverse tangent. Now, I went ahead and wrote southeast. Why did I do that? Because one, I can see from A to B, I'm going south and east. But besides that, I can actually look at my departure and my latitudes. I can see that latitude is negative, so that tells me it's going south, because latitude goes along with the north-south direction. I can see if the departure is positive, and I know when it's positive, it's going east. So that's the nice thing about using the departures and latitudes and having them negatives or positives. So the tangent is departure over latitude, inverse tangent, and it's going northeast, positive, positive. Departure over latitude, I can see that the latitude is positive and the departure is negative, so I know I'm going northwest. So inverse tangent of departure over latitude is 61 degrees, 46 minutes, and 7 seconds northwest. And you keep doing that all the way through. So now I've got the bearings of each of those lines. Typically, surveyors just use bearings in their plats and their legal descriptions, but engineers typically use the azimuths. So we're going to go ahead and figure out what the azimuths are. So we have azimuths that are, I just wrote the equations out there, but we don't really need equations. We can visualize this. So if it is a southeast, it's going southeast. I know it's going to be between 90 degrees and 180. So the angle is measuring down the bearing is measuring off of the south line, so I know I have to take 180 minus that, and it's going to give me the new value. So the next one is the quadrant is in the northeast, and we know that the quadrant, when it's in the northeast, is the same as the azimuth. The next one is, excuse me, we know that it's northwest, so we have to take 360 minus the bearing, and we're going to get 298 degrees. And then the last one is in the southwest, so I have to add 180 degrees to the bearing to get the new azimuth. And in the end, it'll look, so you can see what your northing and eastings, your x and y coordinates are for each point, and the new latitudes and departure, or new azimuths and lengths with the latitudes and departures. All right?